Hey everybody, so I'm hoping Screencast-O-Matic will be helpful for us tonight. I have been somewhat frustrated getting it to work. I think it's more my computer than anything. So we are looking at our relationships of our sine and cosine functions. I know A Block you wrote this down so you can just chill for a second, but my other two classes did not. If we have our sine and our cosine function, we have 5 actually different things that can change. If we have an a, you want to write these two functions down. Y equals a cosine of b times x minus c plus d, or y equals a sine of b times x minus c plus d. Our a is always going to be an amplitude change. Once again, we don't want to describe that as going up. It is a vertical stretch of our function, but we are not physically moving the entire function up. The amplitude change also has, I guess I could put a little note. If it is negative, well, we can't see that color. Let me try a different one. If it is negative, then that is going to be a reflection about the x-axis. I will say that amplitude is always positive. It doesn't matter if it's a -2 in your function, the amplitude is always going to be positive because the amplitude is the height of your function, and height is a distance. Distance cannot be negative. So if I were to ask you for the amplitude of a particular function, you would always tell me that it was positive. The negative only deals with the reflection about the x-axis. It doesn't have to do with the amplitude. We then have another variable b, which is going to be in front of our parentheses. B is actually what we use in order to find our period. Our typical period for the cosine and sine is 2 pi. If we have a b which is different, we are going to divide by b in order to find our period. So our period is always going to be equal to 2 pi divided by b. I will state that b also tells you the number of cycles that you will have in 2 pi, your standard period. As we discussed in class today, if we add or subtract a c, that is going to be our horizontal or our phase shift. That is P-H-A-S-E. Our phase shift is inside the parentheses, just like every other horizontal shift that we have had. And adding something to the end, I just threw this in there, is going to be our vertical shift. We've done horizontal and vertical shift with just about every type of function that we have graphed in the past. So that should not be anything new. If we look at what happens if we have a period shift, and if you'll give me just a second, I'll set myself up. I'm still going to use 3 units to represent pi over 2, 6 units to represent pi. I'm just going to stick with that scale right now because those are the major divisions of our unit circle. As I've said a couple of times in class, I'm sure somewhere in your life you are going to come across a different scale other than 1 unit represents 1/6 of a pi. So our sine curve is always going to start at 0, then we go to 1, 0, -1, and 0. I'm not going to draw it all the way in. I'm just going to kind of sketch it. And so we have our sine curve. If we change our period, a period change is like a horizontal stretch or a horizontal, I want to say smoosh, but that's basically what we're doing. We're either pulling our function out, we're spreading it out horizontally, or we're pushing it in horizontally. Our normal period is 2 pi, and that's incredibly important when we are changing the period, to keep in mind what our normal relationship is. If we have y equals 2 sine of x, that means my period is going to be 2 pi divided by b. Now note, if it were an amplitude change, that 2 would be out in front of the sign. If the 2 is in between the sign and the x, that is going to be a period change. So our period is 2 pi over 2. All of us should know that 2 divided by 2 is 1. So we now have a period of 1. Pardon me, 1 pi. That means we are going to have our entire, sine normally goes up and down. That's one complete cycle of the sine. Instead of that happening in 2 pi, that's going to have to happen from 0, and we've got to be up, middle, back down, and back to the middle by pi. Now, there are some of us who will need to think about our relationship of the sine curve. I'm going to make it up here. Sine starts in the middle, goes up, middle, goes down, middle. There are actually 4 sections. We are increasing, decreasing, decreasing, increasing. So we're going to start at 0, 0, and our period is pi, so that means we have to be back to our final 0, 0 at pi. We should all see that in the middle, we are at pi over 2, and we should be back at 0. What happens here is things start changing. We are still having an amplitude of 1. That means we're going to go up to 1. But instead of going up to 1 at pi over 2, we're actually cutting that in half. We're going to go up to 1 at pi over 4. Because of the scale that we chose to use, we are going to make that smaller. And then we are at 3 pi over 4, we are going to be in the middle. The scale that I said that wrong. Because of the scale that we are using, we're going to have to make that in the middle. We don't have one actual line to represent pi over 4 and 3 pi over 4. Those are going to be in the middle of our pi over 6 and pi over 3. Now, here's one complete cycle, but our period, or our b of 2, says I have to do 2 complete cycles in the time that I normally complete 1 cycle. So I know from pi to 2 pi, I'm going to make a complete cycle. That means we're going to be in the middle. Going to go back up at 5 pi over 4 to 1, and going to go down and then back up. We have 2 complete cycles. Actually, it'd probably make more sense to highlight it. We have 1 cycle here. This is cycle number 1. And then we have cycle number 2, which is why we have a 2 here for our B. We normally do 1 complete cycle from the time we go from 0 to 2 pi. Now we're doing 2. Now in the opposite direction, I'm going to draw this in. We are actually going to go and make a complete cycle by negative pi. And so I'm going to go down and then up. Complete cycle. I'm going to go down and then up, just like we would here. All right, let's look at another example. Let's see. Oh, I was hoping I actually had copied the right thing, but I didn't. Let's copy, paste, so I can get rid of all of this. I'll go ahead and use another sign. Oh, 1, 2, 3, 4. This is my pi. This is my 2 pi. 1, 2, 1, 2, 3, 1, 2, 3. This is my negative 2 pi, my negative pi. I'm going up 1. I'm going down negative 1. And I'm just going to do, since I'll be honest, period tends to get some of us, we're going to do one more example of just straight up. Sine goes 0, 1, 0, negative 1, 0, negative 1, 0, 1, 0. We then are going to talk about what happens if we have y equals the sine of 1/2 x. This makes our b, once again realizing a is in front of the sine, b is in between the sine and the x. Our b is equal to 1/2. Our period is equal to 2 pi divided by b. In this case, it's going to be 2 pi divided by 1/2. Well, 2 pi divided by 1/2, we're going to keep it, change it, flip it. It becomes 2 pi times 2 over 1. In other words, our period is going to be equal to 4 pi. It is going to take the entire graph from negative 2 pi to 2 pi to make one cycle. From 0 to 2 pi, our normal period, you will only see half of the sine. You're only going to see half of it. So what we're going to have to do is we're stretching it horizontally. Our 0 is not going to change. We're going to start at 0. But instead of taking 1/2 pi to get to 1, we're going to take a whole pi to get to 1. And then we are going to come back down to 0 at 2 pi. Sorry, that's not very beautiful. And then we're going to come back down. In the opposite direction, we normally would do this bottom loop between 0 and negative pi. Now it's going to take us the entire 2 pi to go back up to 0. So it takes a distance of 4 pi to complete one entire cycle of the sine. I don't think I was supposed to make a copy. I don't have a lot of time, but I'm going to try to squeeze one more in. 1, 2, 3, 4. 1, 2, 3. Negative 1, negative 2, negative 3. 1, 2, 3. 1, 2, 3. Negative pi. 3. 1, 2, 3. 2 pi. All right. So if we have y equals the sine of x, 0, 1, 0, negative 1, 0. Negative 1, 0, 1, 0. What happens if I want to graph y equals sine of 4x? My period is always going to be 2 pi over b. So in this case, it is 2 pi divided by 4, or pi over 2. That means from here to here, I have to complete the entire sine. I start at 0, I end at 0. My middle is 0. So pi over 4, I'm going to be at 0. 1/8 of a pi And 3/8 of a pi is where I am going to have my maximums and minimums. So I am actually starting at 0, ending at 0, middle is 0.